With most fluid power applications, the design process starts by determining the force, speed, or torque required to accomplish the job. Force is defined as a strength which, if sufficient, will cause motion in a movable body. It always acts in a linear motion and in fluid power is applicable only to cylinder operation. In the case of this double-acting cylinder, the pressure from the fluid acts on the area of the piston. The resultant force causes the piston to move. The force produced by a cylinder can be found by multiplying the pressure times the area of the piston surface against which the fluid is working. This area is called the working area. For a round piston, the circular area can be determined by a well-known formula. Area equals pi times r squared. However, most cylinder pistons are identified by their diameter. By substituting the appropriate values for pi and diameter, we can simplify this equation to area equals 0.7854 times diameter squared. The full piston area is the side of the piston without the rod. This is the area that sees pressure as the piston extends. The other side of the piston is called the net area. This area is the size of the full piston area minus the area of the rod. The net area feels pressure when the cylinder retracts. The force equals pressure times area equation can be used to determine the force on either side of the piston. Use the appropriate working area when calculating the force. The speed at which the piston extends and retracts is calculated using the volumetric flow rate times the area for the incoming fluid. Since each side of the cylinder has a different working area, each side experiences a different speed. Let's assume that the volumetric flow rate is equal for each inlet, meaning fluid enters each end of the cylinder at the same speed. Because the rod takes up space within the cylinder, less fluid is required to fill the rod end side. Therefore, fluid will fill the rod end side more quickly than it will fill the blind end. Since the rod end side fills more quickly, this type of cylinder will always retract faster than it can extend. The rate at which a particular volume of fluid moves through a system is called the volumetric flow rate. The volumetric flow rate is commonly expressed in either cubic inches per minute or gallons per minute. In order to calculate speed in inches per minute, we need the volumetric flow rate expressed as cubic inches per minute. To convert from gallons per minute to cubic inches per minute, multiply the volumetric flow rate in gallons per minute by 231. A torque in a rotary device is the counterpart to force in a cylinder. Torque is defined as a strength which, if sufficient, will cause rotary motion in a rotatable body. Torque can be mathematically expressed as a force times a lever arm distance. When the force and lever arm are not perpendicular, the lever arm is calculated as r times the sine of angle theta. Motors produce torque by fluid acting on gears, vanes, and pistons, which produce a twisting motion on a shaft. Knowing and understanding the force, speed, or torque required will assist the design team with determining the most appropriate fluid motor or actuator for the job.